sure you want to go right now? I will not tell you no, but unlike bases.
I'll be really fast. You're gonna miss the easy one because I'm like back to the hard one. Probably.
All right, so let's talk about unlike bases in terms of the just fractions from elementary. So back in elementary, let me write it down here so it doesn't get confused with these at all. Let's say I had you guys add 2/3 plus, let's do, perfect, 1/2. Now our denominators are not the same, so what did we have to do back then? Yeah. What would I have had to do to get these to be like denominators? Yeah, so if they're not the same at all, in this case, multiplying the opposites together would be the easiest way to do it. So this fraction, you would multiply by 2. Remember, you have to do both of it by 2, so that you're not changing the fraction. This one over here, then what would you multiply? Very good. Okay. So this fraction, what would it become?
4/6.
Very good. So that becomes 4/6. And then what would 1/2 become? 3/6. Very good. So now we have them in like denominators, and then you can just add the top. So what would I get?
7/6.
So when you're doing that, are you always just like multiply the 3 times the 2? Like every time? Does that make sense?
No, but yes, it does make sense what you're saying.
Okay.
You'll see it, and if you had something like, let me think of a good one. Actually, we're going to get there in a second. I'll give you another example of that here in a moment, because these first ones are like that.
Okay.
All right, so if we look at number 1, it's very, very similar. We have 15/2x minus 16/3x. So the 2x and the 3x, they both have an x, so I don't want to multiply any variables because they both have that in common. But the 2 and the 3 we need to get to match. So what would I multiply these fractions by? 2 and 3, just the opposites, just like we did here. So this one I'm going to multiply by 3. This one you would multiply by 2. So 3 times 15 would give me 45. And then 3 times 2x would give me, and then we're subtracting. What's 16 times 2? And then 3x times 2. What is 45 minus 32? You have 13 on the top, 6x on the bottom. This would be a simplified as everything. We did.
Okay, we just finished that.
All right, any questions on number 7 before we do number 8? If you pick up right with number 8, you'll be okay, Hannah. All right, so for number 8, we have a squared and we have 8a, and we need to get those to be like. So what would I need to multiply by? And this one I have to multiply by 8, right? So we need to get an 8. So 8 to the bottom and the top. What would this one need? So this one's going to be 8a squared. How would I get this one to be 8a squared as well? Multiply by 8, right? Everybody with me so far? Okay. So now 8 times 4a, what would I get there? 32a, good. And then in the bottom we should have 8a squared. I keep these separate just to make sure I did in fact multiply by the right thing. So 7 times a would obviously give us 7. 8a times a would give me 8a. Perfect. Okay, so now our denominators match. We need to do 32a minus 7a. What would I get there? And on the bottom we have 8a squared.
Wait, would you take the square root or not use that?
We would take the square root, but we can simplify that further. 25 and 8 cannot be simplified. So that's going to remain there. But what happens to the 8?
Oh, it's just 25 over 8a.
Perfect.
Why don't you put the squared thing?
Because a over a squared, we subtract.
See, I got it.
You do. Good job.
Did you cut your hair?
I did. I got it way chopped. Oh,
yesterday. And I was like, hey.
Fractions, you don't need the simplified examples? Or does that help?
It helps.
If we had something like, okay, the example has nothing to do with this, just to not confuse anybody. Let's say we had 1/8 plus 1/2. I don't need to change both of them, right? Because I can get that 2 to be an 8 very easily. So what would I multiply the 1/2 by? 4, very good. So I'm not changing the first one at all, but I am changing the second. So what does 1/2 become? 4/8. Now we have like denominators. Notice I didn't change that first fraction at all. So 1 plus 4 would give us 5. 5/8 does not reduce. Okay, so it's going to be similar to what you might see in some of these, where you don't have to change both. Looking at number 9, if you have something like 5k minus 10, what might be easier to do is go ahead and factor that bottom part. So what would 5k minus 10 factor to? Yeah, take the 5 out. What's that?
Can't you just multiply by 5 and get the same thing?
We will, but I'm going to show you just to make sure as they get more complicated. Alright, so if I take a 5 out, I'm left with k minus 2. So then you can easily see we have 5 times k minus 2 in the first one. The second one is only k minus 2. So you only have to multiply by 5. If you see that ahead of time, that's fine. Now you're going to factor it eventually. But if you see that first, you wouldn't necessarily have to do that.
Oh, I just multiplied it by 5.
Yeah. And you can do that, but like this one, we definitely want to factor.
Yeah.
So I'll just try to keep the steps the same. Alright, so if I multiply the second one by 5, this k squared plus 16 stays the same. We have 5k minus 2. Alright, 4 times 5 would give me 20. On the bottom, we have 5k minus 2. I'm not going to multiply them together because I have to factor them anyway. So in the top part, what would I end up with when I combine them?
36.
When do you take
K
the
squared plus 36.
Wait, how are you getting 36?
Oh, I
Oh, wait.
Gotcha. So we're subtracting again.
You get
4, very good. Negative 4, right?
2 minus 4. And then you do the square root.
The difference is squared.
Yeah.
We had k squared minus 4. And what would that become? I think Tiana's already got it.
K minus 2, k plus 2 over 5. K minus 4. And then you cross it out, you get k plus 2 over 5.
I'm gonna write it over here. It's a little bit extra stuff in there to get those denominators the same. But other than that, it feels very similar to what we did in section 1 once you get it combined. Any questions on number 9 before we try number 10? You ready? Alright, so number 10, we have y plus 8 and y squared 11y plus 24. So what do I need to do first? Sure. Yeah, we're going to go ahead and factor that second trinomial, or second denominator, which is a trinomial. What would y squared plus 11y plus 24 factor to? 3 and 8, good. And they're both positive, right? Now do you see what's common between the two different denominators?
So you only have to have one that's common? Like, not the whole thing.
Yeah, we have to figure out what to multiply the first one by looking at
Oh,
the
so
second.
so yeah, you know.
So that's the first one is y plus 3. Luke was right. So we're going to multiply this by y plus 3 over y plus 3 and leave them separated. Don't foil the bottom part together. We'll have to put the top part together. What would y plus 3 become? You're right, 7y. 7y plus 21. Does everybody know where I got 7y plus 21?
No.
By taking the 7 and multiplying it by both pieces.
Okay.
Alright, and then this part we still have 35, and if it doesn't confuse anybody, I'm going to go ahead and write y plus 3, y plus 8 on the bottom. I combined the step together. Alright, so now what do I need to do?
21 plus 35.
Very good, and what do you get?
6.
So I say 7y plus, what do you say?
56.
That's over y plus 3, y plus 8. Alright, now what do I have to do? Very good, we take out a 7 in the top. When I take out a 7 in the top, what's left over? On the bottom still is y plus 3, y plus 8.
7 over y plus 3.
Very good, because the y plus 8 will cancel out, leaving you with 7 over y plus 3. Do you need more room for these problems? Or maybe I just do, maybe you guys do it. I don't know. Alright, what questions do we have so far? Does this feel comfortable? Ooh, like you guys are getting it. I'll let everybody finish rating and then we'll go over number 11. Alright, number 11 was x squared minus 5 over x squared plus 5x plus 6 plus 1 over x plus 2. So what is my first step? What should I do?
Do the bottom factor.
Yeah, let's go ahead and factor that one. So x squared plus 5x plus 6, what would that factor to?
2 and 3.
Very good. X plus 2, x plus 3. And so what do I need to add to the second fraction? X plus 3, good. And the top and the bottom. Alright, so now we have common denominators. So I'm going to write them all together. Just put them over x plus 2, x plus 3. I'm going to write the bottom first. Alright, so in the top, we have this 1 times x plus 3 is just x plus 3. I'm going to combine it all at once if this doesn't mess anybody up. Make sure you know where I got all of that. We need to clean up the top. How does the top clean up?
X squared plus x plus 8. Right?
X squared plus x. It wouldn't be 8 though because we have this minus 5.
Oh, shoot, I meant plus. My bad.
What did you say?
I wrote it down a plus instead of a
I
minus.
thought you paused on that one.
Oh.
Did you?
No, I didn't. I said shoot. No, I actually didn't.
I did. Alright, so now we need to factor the top. What would the top factor to?
Go ahead. 1 and 8.
Oh, the top part.
Oh.
Very good. And which one's positive? Which one's negative? The one's negative. Right? So we have x plus 2, which is convenient. X minus 1.
Oh, you already.
I think you said 8 originally, but it was an 8.
Yeah.
How did you get that?
This part?
Yeah.
So the factors of negative 2 to give us a positive 1. We need the
Okay.
2 to be positive, the 1 to be negative.
So if I write down 1x, is that okay? Instead of just x?
Oh, yeah, that's fine.
Okay.
I don't know.
Alright, then what cancels out?
X plus 2.
Alright, final answer over here. So we're left with x minus 1 plus 3.
It's gonna get harder to feel it. Oh no, we're gonna divide next. No. Oh. We're dividing. We're dividing fractions.
Where do you see division?
On the next page.
Oh, you're looking at the net. Okay, I got it.
Yeah.
Complex fractions. I thought you were looking at the rest of these.
No,
Like, I don't see division anywhere.
How hard is that?
Question